In this video, we're going to do a practice particle motion problem together and see how all the formulas and stuff that you learned in the last video relate to real problems. So, for t between 0 and 12, a particle moves along the x-axis. Okay, this tells us that we are dealing with one-dimensional particle motion because it's moving along the x-axis. We're given the velocity, and it's this function here. And we're also given an initial position. The position at t0 is -2. So we can say that x of 0 is -2. That might come into handy later. Alright, let's go through the problem and figure out what to do at each point. At least like starting off. So when the particle is moving to the left, alright, remember that's a key phrase from the last video. If the particle is moving to the left, we're looking for where the velocity is negative. Alright, in part B, we're looking for an expression for the total distance. Okay, there was a formula for total distance. You're going to use that here. As you recall, the formula for distance is the integral of speed dt. Okay, that would be part B. And then for part C, we're needing to find two things. We need to find a of t, so we're probably going to take the derivative of velocity, dv dt, and plug in 4. And then we have to find out whether or not the particle is speeding up or slowing down. And so we're going to look at whether or not we're going to look at the signs of a and v at t equals 4 to see if they have the same sign or different signs. And then the last part is find x of 4. Okay, if we're finding x and we have v, we're going to integrate v of t to get x of t, and that's going to be our starting point for part D. Alright, so let's go through each part. Part A said, when is the particle moving to the left? And we said that this is going to be where v of t is negative, because that means moving to the left. So to do this, we take v of t. We had an equation for it. It was cosine pi over 6t. And we're going to set this equal to 0 to find where the sign changes are. Okay, cosine stuff equals 0. So let's think about our unit circle. And the x value, the value here where cosine is 0 is going to be at pi over 2 and 3 pi over 2 and let's see, going around 5 pi over 2, etc. Blah blah blah. And so these are going to equal pi over 6t. So I'm going to divide each of these by pi. So divide by pi, divide by pi, divide by pi, and then I'm going to multiply each of them by 6. So to get rid of the 6. So 1/2 times 6 is going to be 3. 3/2 times 6 is going to be 9. 5/2 times 6 is going to be 15. And 15 is too big because it's outside of our time interval, remember, going from 0 to 12. So the only two solutions are 3 and 9. Well, we need to figure out when the velocity is negative. So let's think about the graph of cosine. Cosine starts at 0 and then starts positive and then drops down and then drops back up, etc. And we know that these x-intercepts are going to be at 3 and 9. So this is a graph of our velocity. We want to know when velocity is negative. Velocity is going to be negative in between 3 and 9. So our answer will be 3 less than t less than 9. And that's basically, it's almost a pre-calculus question, finding out where a graph is negative. Alright, moving on to part B. Write but do not evaluate an integral expression that gives, here's the key word, total distance. And so really this is an easy part because all we have to do is write the total distance formula. So our distance is the integral of speed, or the easier way to remember it is just the integral of the absolute value of velocity, dt. Don't forget the absolute value signs, that is important. And then let's just plug in all the information. So we're going to go from 0 to 6, because that's what it says. And then our velocity function was cosine of pi over 6t dt. Nope, sorry, we don't need the dt until after the thing. And it says do not evaluate, so guess what? We're done. That is the distance. And it might be good to label it as distance. Always good to clearly label your answers. But that's part B, done. Alright, part C says to find, the first part is to find a of 4. Well, a is going to be the derivative of velocity. So, let's take the derivative of cosine of pi over 6t. Alright, to do this we're going to have to do some chain rule. First off, the derivative of cosine is the outermost function, so that's going to be negative sine. And then the inside stuff stays the same, pi over 6t. And then chain rule, pi over 6. Alright, and we do need to find it at t equals 4, so we're going to plug in 4. So we get negative sine of pi over 6 times 4, oops, like that, times pi over 6. And it is okay to leave this answer like this on the free response. However, I'm going to simplify it, and I suggest that you do also, because it's going to help us with the second part, because we have to figure out if this is positive or negative. So the sine of 4 pi over 6, well, 4 pi over 6 is the same as 3 pi over 2, and so the sine value there is going to be root 3 over 2. So we have negative root 3 over 2 times pi over 6, which will simplify to negative root 3 pi over 12. And that would be the acceleration. Awesome. Now, to find if the particle is speeding up or slowing down, we need to look at two things. We need to look at the sign of A. Guess what? A is negative, because we just found it, and it's negative. We also need to find V at 4. Well, this is going to be pretty simple, because all we have to do is plug in 4 into our velocity equation. So we're going to do cosine of pi times 4 over 6, and again, 4 over 6 is going to be 2 pi over 3, and the cosine of 2 pi over 3 is negative 1/2 from the unit circle. And so we get that A is less than 0, and V is less than 0, and so therefore, because A and V have the same sign, so same sign, therefore, the particle is speeding up. Therefore, particle is speeding up. And so that's what you look for if the particle is speeding up. You look for A and V having the same sign, which they do, so therefore the particle is speeding up here. For the last part, part D, we're finding x of 4. So remember that in order to find position, x of t, this is going to have something to do with the integral of velocity. Because to go from v to x, you're going to take the antiderivative. So we have to use the fundamental theorem because we are finding the position at a specific time. So the way we do that is we plug in t equals 4 into one of the limits, and we're also going to plug in a t value down here that we do know the x value at. Going back to the original problem, that would be t equals 0 because we know the position at t equals 0. So we're going to integrate from 0 to 4 of v of t dt, and this will be equal to x of 4 minus x of 0. Alright, I'm going to take this to the next page so we have a little bit of room to work, but this is our starting point. This is the fundamental theorem of calculus, rewritten to help us. So I have the integral from 0 to 4. Plugging in the velocity, we get cosine of pi over 6t dt, and this will be equal to x of 4 minus x of 0. Alright, let's integrate cosine. I do have to do a little bit of a u sub here because I have stuff inside the cosine. So the u is pi over 6, so pi over 6t, therefore du is simply pi over 6 dt. I doctor with a pi over 6, and I counterbalance with a 6 over pi. Yes, it's weird, but that's correct. So I get 6 over pi times the integral of from 0 to 4. Technically those limits are wrong, but I'm gonna go back to t's at the end anyway, so it won't matter. Of cosine of u du, because we've done the u sub, and the antiderivative of cosine is sine. So we have 6 over pi sine of the u, which was pi over 6t, and we're going to evaluate this from 0 to 4. Right? If I plug in 4, I am going to get 6 over pi, and the sine of 2 pi over 3 is going to be root 3 over 2 like it was before, minus, plugging in, again the 6 over pi stays there for both, okay, because it's constant multiplied. And if I plug in 0 into this, I get sine of 0, which is 0. So that term is going to go away. But this is going to be equal to x of 4 minus x of 0. And if you recall, x of 0 was negative 2. So in order to move that over, I'm going to add, this will be a plus 2. So I'm going to subtract 2 from both sides. And so my answer, x of 4, will be equal to 6 over pi times root 3 over 2 minus 2. And you could simplify this fraction if you wanted to, but it's okay if you don't. And that's it. So make sure you have this in your notes. It's a good problem to look at and reference when you're doing classwork or doing AP practice. So hopefully you enjoyed this and it made sense. Bye.